Welcome to this tutorial about my asset Planetary Terrain. This, combined with the included documentation PDF, should be enough to get you started. If you still have any questions, please contact me via email, the forum thread, or Unity Connect. I also encourage you to look at the sample scenes, which you can find under Planetary Terrain Scenes. Anyway, let's create our own first scene now. First, I like to get rid of the skybox, so let's do that. That should do it. Now we have a solid black background. Okay. Now you can create your planet with GameObject, 3D object, planet. Basically all this does is create an empty GameObject and attach the planet script. The planet is at 0, 0, 0 and its radius is 10,000 units. So to avoid being inside of the planet and not seeing anything, we have to move our camera back. Also increase the far plane distance so that we're actually able to see the planet. And that should do it. Now we can see the planet. If you go into scene view and switch to shaded wireframe shading mode, then you can actually already see the LOD system in action. If you move the camera farther away from the planet, then we'll get low resolution quads. If we move closer, then we get higher resolution quads. That works, but the planet is still very flat. So let's give it some actual terrain. There are many ways to do this, but most of them start with the node editor. You can create a new node graph and open it by double-clicking. You'll probably get this Xnode window. I like to have it as a tab up here. Anyway, in here you can create nodes with a right-click. Most important nodes right now are saving node and generator node. The generator node just represents some kind of noise and outputs that. Then you can do things with that noise like invert it, for example, with an operator node. And you can save that graph with the saving node, which serializes it into a file that can actually be used by the planet. For now, let's not use any operator nodes, just a generator and a saving node. There's also the preview node, which you can use to get a preview of the height map. So this is an equirectangular height map, so you have North Pole, South Pole, and equator. There are also a couple of noise graphs included in noise modules, source noise graphs, namely the one used for the Earth-like planets. If you look at the preview here, you can see continents and an ocean. Anyway, for now we'll stick with the simple generator and saving node. You can give your serialized noise module some name. I'll just call it tutorial. Then you serialize it and then it appears in your assets folder. This file represents our node graph here. And now we want to assign it to our planet so that it uses this file or this node graph for terrain generation. In the generation tab of your planet, you can define the generation mode or what data it will use for its terrain. Currently that's constant, that's why it was flat. And we now want to use the noise mode. You can assign your serialized node graph and press play. And now you have terrain. If you want to make the planet flatter again, you can decrease the height scale. Now the noise has less impact on the actual surface of the planet. Or you can increase the height scale. Now the terrain will be rougher. Let's leave it at 0.1 for now. let's also attach the included camera move script to our camera, so we can, well, move the camera. And this is our planet. Now we have terrain, but the planet is still very white, so let's texture it. To do that, you need to create a new material and give it some kind of texture. A couple of textures are included. I'll just use this grass texture and turn down the smoothness. Okay. Under the visual tab, you can assign your material, and you need to select a UV type. For now, we'll use the quad UV type. Now we have a textured planet. But that same texture is used everywhere. What if we want to fade between it and a second texture based on height though? To do that, change the type of your material, or the shader of your material, to Planetary Terrain Planet Surface Shader. And now you have 6 different textures between which the material can fade based on height. We'll only use the first and second, or 0 and first texture. For now, select the grass texture and maybe a grass rocky texture. Turn down the smoothness, and this is our material. It's already assigned, so we don't need to worry about that, but we still need to define which textures to use at which height and such. To do that, you need to edit individual tab texture IDs and texture heights. Unfortunately, there's this Unity bug right now, which sometimes doesn't allow you to extend an array or see the extended array. So you can use the debug tab if you also have that. I reported it and they should fix it soon, I hope. Anyway, for now, since we have 2 textures, let's make texture heights and texture IDs size 2. We need to set both arrays to 0 and 1. We're basically setting key points here. At height 0, use texture 0. At height 1, use texture 1. And otherwise, fade between those 2 values. Okay, save that. Now at higher elevations, this texture is used. If you want to increase the tiling, just increase texture scale right here. If you want the fading to start later, you need to add another key point between the 2. Let's make both arrays size 3. Do something like this. Now we're saying between height 0 and 0.8, fade between texture 0 and 0, i.e. between height 0 and 0.8, we always get texture 0. And between 0.8 and 1, fade between texture 0 and 1. So the fading starts later, which is clearly visible as there is almost no more of the second texture. Let's make it start at 0.5 maybe. 0.4. Yep, now we have it here, but it starts later. Now let's make the planet bigger. Unfortunately, it isn't as simple as increasing the radius, but it's a good start. Start by making that radius 50,000. We also need to move the camera farther away, obviously. Turn it inside the planet. And next, we need to edit the detail distances. Detail distances are distances at which a quad will split. Set these. You can use the detail distances generator. a good start value is usually something like the radius times 5, times higher numbers if you want more detail, times lower numbers if you want less detail. Just basically just starts with the start value and then divides it by 2. This usually works out pretty well, but if you want further optimization, then you might need to hand tune these. Okay, now the planet is bigger, but well, you'll notice one problem. The far plane is too close. The camera doesn't render the whole planet. Now we could just move the far plane farther away once more, but that would cause all sorts of z-buffer issues, so it is to be avoided. Let's use a second camera instead. Our first camera will render everything closer than 5,000 units. The second one will render everything farther away. To do that, create a second camera as a child of the first one.
Set the first one to depth only and make its depth bigger than the second camera's. Also set its far plane to 5,000 units. Next, disable the skybox for the second camera and set its clipping planes. Its near plane is going to be at 5 kilometers because that's where the first camera stops rendering, and its far plane is just going to be very far away. And now we can see the whole planet and don't have any z-buffer issues.
Another issue that we get with large planets at large distances is floating point inaccuracy. It isn't very visible when you just fly around like this, but as soon as you'd start adding rigid bodies to the scene, you'd start to see some twitching and issues with them. So to fix that, there is the floating origin script, and floating origin is insanely easy to set up. Just add floating origin to your planet, also assign it to your planet, and then make your main camera the player transform. You don't have to worry about this because we don't have any objects, nor do we have any planet other than this one. Now we'll move the origin when the camera is too far away from it. See, even though the camera was at minus 55,000 units, as soon as we start, it is moved to 000 and the planet is moved to plus 55,000. So basically, the camera is kept close to the origin and everything else is moved every time you see this moving origin message here. And since your rigid bodies are usually close to the camera too, they won't be affected by floating point inaccuracies, and the planet doesn't really care.
That was the first tutorial. I hope it was helpful. Have fun.